We are taking R.D. Sharma solution, class 12, chapter is 19. The exercise is 19.27 of indefinite integrals. Now this kind of question where we have e raise x sine bx plus c. So we have already dealt with e raise ax sine bx or e raise ax cos bx. Now this addition of constant, what will happen? What will change? So we'll try to prove this and solve this. If you take this I late, you know that this is inverse, log, and then algebraic, trigonometric, and exponential. So this t and e, trigonometry will come first, the function will be first, and then exponential will be second. So we'll take this trigonometric as the first function, e raise ax as the second function. Now applying the formula of u into v, that is two function multiplied, how to do the integration of that thing. You already know the formula like this. Start with the u, then integration of v with respect to dx, minus integration of differentiation of first function, then the integration of the second function again with respect to dx, and then we will integrate this again with respect to dx again. So we are applying same thing here now. So we have this sine bx plus c as u, e raise ax as v. So this integration will be applying this formula. How this will be formed? First is sine bx plus c, which is u, and then the integration of v, which is e raise ax, and then integration of du by dx. What is u? Sine bx plus c. So the differentiation will give you what? d by dx of sine bx plus c will be cos bx plus c. That I'll show you just now. Let's complete this integration of ex dx again. So once you do all on the right, you have to integrate it again. So e raise ax will be simply e raise ax, and then the differentiation of ax will be a, that has to be in the denominator. Then sine bx c will remain like that. d by dx of sine bx plus c, it will be cos bx plus c, because we are differentiating. It will be cos bx plus c. Then we have to differentiate bx plus c also. b will come then. Then e raise ax, we have already done that. E raise ax divided by a. And then this has to be integrated again. Now this b and a I am taking in front of integration sign. Now you have to do this in a different step, but you already know that b and a are already there, so I can just show you here that b and a can be taken outside. Now e raise ax into cos bx plus c is in itself a new integration. So let me call it as some I1, and you will see that will be a reincarnation. That means the actual integration from where we started will come again, and this will be going on loop. So we'll stop that loop and I'll show you how. So this e raise ax cos bx, which we assigned as I1, will be integrated in a separate way. Then we'll join it along with that I. So this I is I1 is u as cos bx plus c, v as e raise ax. That is, first function we will take as per I late. First function will be cos bx plus c, second function will be e raise ax. So this will be cos bx plus c, this is the first function. Integration of e to the power ax minus, and then d by dx of cos bx plus c. Then the integration of e raise ax again with respect to dx. And once this is done, we'll again integrate it. So e raise ax will be e raise ax divided by a. Cos bx plus c remains unchanged, minus d by dx of cos is what? Cos is minus sin x. Differentiation of cos x is minus sin x. So I'll just change the sign, because when it comes as negative cos bx plus c, this negative will become, because we can take this negative outside, it will become positive, and this b I can take outside. Cos bx plus c remains like this inside. Cos will be sine. So let me write sine bx plus c, and this e raise ax will be integrated. So e raise ax divided by a will come, as we have just done here. So I am taking a outside. So the constant which has come, I have just taken it outside the integration sign. But what do you see here? Why I have taken this constant outside? So this is, I was saying that there is a reincarnation. Sine bx plus c e raise ax is the actual integration, and that has come up again. So this b by a, integration of b sine bx plus c e raise ax will be I. This I1 will be what? E raise ax by a, and cos bx plus c plus v by a I. So this I1 has started from here. So we will keep this thing alive, and now this part which we assume to be I1, we will substitute the I1 which we got just now. So we'll replace equation number 3 in equation number 2. So this I has come like this: e raised ax sine bx plus c and divided by a. Then we have, what was I1? I am now replacing I1. So there was b by a, and inside this we'll replace it by I1. So it will be e raised ax cos bx plus c divided by a plus b by a I. Now we'll multiply b by a inside. So e raised ax by a sine bx remains unchanged. Now multiplication will give you b into e raised ax cos bx plus c, and the denominator it will be a square. So the numerator will be like that, but b by a into 1 by a will be b by a square. Then minus b into b will be b square, a into a will be a square, minus b square by a square into I. Now this whole goes on the left here. So it will be I plus b square by a square into I is equal to, now you can take something common from here, and you also have to do the LCM thing. So we'll make it as a one term. For that we'll take a square as the denominator, that is the LCM. So the right hand side a square is already there. So the numerator will only come b into e raised ax into cos bx plus c. Now the first term, because it is a in the denominator, a has to be multiplied in the numerator. So e raised ax sine bx plus c will come. Now the left hand side, which is I plus b square by a square plus I, let me do it here. I am taking I outside, so it will be 1 plus b square by a square. So this I will be a square plus b square by a square, and this is I into. So on the left I will write a square plus b square by a square into I is equal to, now e raised ax can be taken common also. So we have a e raised ax sine bx plus c minus b e raised ax cos bx plus c, and this a square. So you can cancel this a square, and I was suggesting this a square plus b square has to be taken downstairs on the right hand side. So e raised ax can be taken common. So e raised ax I am taking common. A square plus b square can be brought in the denominator, and the inside will be a sine bx plus c and minus b already there cos bx plus c. Alright. So this is an indefinite integral, so you have to add a constant of integration. Okay, this is how this will be solved or proved. Now sometimes you will understand that e raised ax sine bx and e raised ax sine bx plus c are same. They are not. So let me show you the proof also in a printed form so that you can try it by yourself, or you can remember it how to write this if it at all comes in your examination. Cos log x dx. Now there are certain ways in which we can go about it or proceed to solve it. Now you can just do like this, 1 into cos log x. This is one way, and you can apply the isolate rule and you can go about it. But you can see that log x is already there, and since we are doing this exercise, log x and e raised x are quite interrelated. So if you take log x as t, that means e raised power t is x. Let me remind you that log base a b equals to c is nothing but a raised c is equal to b. So same concept here. Now we have assumed something and we have to substitute later also. So let me mark it as 1 and 2 equations. So x equals to e raised t, we need to differentiate it also, because if you're substituting somewhere or assuming, you need to think about all the content in the question, because dx is already there. So dx by dt will be equal to e raised t, dx will be equal to e raised t dt. Now this dx is what? You have to substitute this because everything you have taken in the form of t. So now this equation will be transformed after all this assumption or this substitution. I will be equal to integration of what is cos log x. In place of log x you can write t. In place of dx you have to write e raised t dt. Now e raised t cos t dt, we know the formula directly. That is e raised ax cos bx. If you remember, integration of e raised ax cos bx. Now most of the people will tell you that if you remember this formula, just apply it here. But I will not second it. I will recommend that you solve it in the way integration is done, because e raised ax cos bx, when you prove it, then the final result will come, and you can just put this a and b, and then you can just solve it using the formula only. But I will encourage you not to use the formula, use it as the integration is done. So first function is cos t here, second function is e raised t here. We will apply the same result, that is integration of u into v into dx. This u and v are the first function and second function. So I will be equal to cos t integration of e raised t minus integration of differentiation of cos t, then integration of e raised t. So dt will come here, and then dt. So I will come like this. E raised t will be e raised t only. Cos t is unchanged. D by dt of cos t will be minus sin t. So this will become plus sin t inside the integration. E raised t will remain e raised t. Now e raised t sin t. E raised t sin t dt. So this I1, call it as I1 because we will do this I1 separately and then we will replace it. So I1 is a separate thing which we are doing. So this first function will be sin t, second function will be e raised t. This will be sin t, integration of e raised t dt minus integration of d by dt of sin t, integration of e raised t again with respect to dt, and this final will again be integrated. So this is sin t, e raised t will be e raised t only, minus d by dt of sin t will be cos t, and e raised t dt will be e raised t again, and dt. Now why we did this? Because I was initially, when we did some substitution or assumption, we started with this I only. It's e raised t cos t dt. So e raised t sin t will remain like this, minus cos t e raised t will be I. This is your third equation, I1. Now we are replacing this I1 in our I from where we left. So I will be e raised t cos t. This I1 will be taken from equation number 3, that is e raised t sin t minus I. Now this I can be taken on the left hand side. So this I plus I will form 2I, and this will be equal to e raised t cos t e raised. So you can take just e raised t common from here. 2 you can bring downstairs on the right hand side. So cos t plus sin t will come, and this I will be what? Because now you need, because you assume something, so you need to substitute them in at the last. So e raised t was x, cos, in place of t you can just write log x. So cos log x plus sin log x, this t again with log x, and plus a constant of integration. This is your final answer. So just having the formula and solving it will not solve the purpose. You have to do it exactly the way it has to be done. And this is the printed version. So if you're writing by yourself or in the examination, you have to do something like this. Now we have e raised to x cos 3x plus 4. Now many people will say that there is a direct formula in the exercise or in the r.d.sharma or any other book. You can just apply that formula and just write, and that is finished. No. If they are saying, or you are adopting this, see, e raised ax, and what is a and b? A is 2, b is 3, and c is 4, because it is the form of e raised ax cos bx plus c. So we'll do it in the way it should be done, as integration of two different terms. So we'll apply ILATE. Trigonometric function will first, exponential will be second. So u will be cos 3x plus 4, v will be e raised to x in this case. So integration of u and v dx you already know, and I'll just apply that here. So this I will be, so it will be cos 3x plus 4, and then the integration of e raised to x dx minus integration of then differentiation of cos 3x plus 4, and then the integration of e raised to x dx, and then again it has to be integrated again with respect to dx. So e raised to x will be e raised to x by 2, cos 3x plus 4 remains like this, unchanged. Cos is a negative sign, so minus minus positive, sin 3x plus 4. When you differentiate this, 3 will also come out. So 3 I am bringing outside. E raised to x will be e raised to x divided by 2. So e raised to x you can write, and that 2 I'm bringing outside. As constant all I'm bringing outside. Now e raised to x sine 3x plus 4 is again an integration of this sort only, or this type only. So let us call it as I1. We will integrate this I1 and we'll replace it later. So this I1 is integration of e raised to x sine 3x plus 4, and this has to be integrated. Again eilate will be applied, cos or sine, these are all in trigonometric things. So this sine 3x plus 4 will come first, integration of e raised to x with respect to dx minus integration of d by dx of sine 3x plus 4, and then the integration of e raised to x dx again, and then final integration with respect to dx. So it will be sine 3x plus 4. This will be e raised to x divided by 2 minus d by dx of sine 3x plus 4 will be what? Cos 3x plus 4. Then 3x plus 4 will be differentiated again, 3 will come outside. E raised to x will be again e raised to x by 2, 2 I am bringing outside again. So this is the integration which we called as I1. Now this is what? This is the original equation which we started. Alright. What was I1? I1 is e raised to x divided by 2 sine 3x plus 4 minus 3 by 2, and this is I only. So I am writing I. Now this I1 has to be replaced here because from here we left. I told you we will do I1 separately and then we will shift this I1 into the original equation where we left. So I becomes e raised to x by 2 cos 3x plus 4 plus 3 by 2, and inside this replace I1. So e raised to x by 2 sine 3x plus 4 minus 3 by 2 I. So I will become like this, e raised to x by 2 cos 3x plus 4, and then plus 3 by 2 needs to be multiplied inside. So 3 by 2 to the 4 e raised to x sine 3x plus 4, and 3 by 2 into 3 by 2 will be 9 by 4. So minus 9 by 4 I. Okay, negative 9 by 4 we will shift it on the left hand side and we will add it with I. So I plus 9 by 4 I. This I will come out 1 plus 9 by 4. 4 plus 9 by 4 that will be. So this will be 9 plus 4, that is 13 by 4. So this whole will be 13 by 4 I on the left. So 13 by 4 I is equal to, now you can take e raised to x common, and also you can take the denominator as 4. That means you can take the LCM of these two. Since we have a base as 4 in the numerator, you have to multiply 2 with cos 3x plus 4 because only 2 is in the denominator, and we have taken 4 as the denominator for LCM. And since 4 is already there with the sine term, so it will remain like that. You just have to do that. It will be 3 sine 3x plus 4. Now this 4 you can cancel. You can bring this 13 in the downstairs of the right hand side. So I will become like this, e raised to x divided by 13, 2 cos 3x plus 4 plus 3 sine 3x plus 4, and that's your final answer along with the constant of integration. This will take later. Till then, thank you so much. Have a good one.